My first program is simpler than blinking an LED. Two buttons, one turns the data pin high, other turns it low. The receiver reads the pin and shows the value as 1 or 0 on an LCD. And it works. Now the receiver needs memory to store the previous bits in order to turn that into data. In this video, I'll build data communication from scratch. No UART, no magic, just voltage, timing, and logic. I'm using two AT89S52 microcontrollers, one sender, one receiver. These MCUs have dedicated TX and RX pins, but I'm not using them. I'll use a normal I/O pin to show there is no magic. Now the receiver needs memory to store the previous bits in order to turn that into data. So I programmed it to store the incoming bits in an array. It kinda works, but immediately we hit a problem. I can't store two ones or two zeros in a row because I programmed the receiver to store a bit only when the value changes. To solve this, the receiver needs a way to know when a new bit is coming. It needs some kind of signal to read the data when a button is pressed. But a single data pin cannot send the data and the signal at the same time. There are two ways to solve this, and I'll build both. Early engineers solved this by adding another wire. One wire for data, one wire for a pulse or clock. Every pulse means a new bit is coming. It is called synchronous communication. The pulse wire remains high at idle. At button press, it turns low for a few milliseconds and then turns high again. The receiver reads the data pin at each pulse. Now I can send two ones, three ones, anything. The receiver knows exactly when to read. But pressing buttons is not an efficient way to do this. It's time to automate. So I hardcode a byte 10110011. It doesn't have any special meaning. It just came into my mind. When I press a button, the sender sends all 8 bits serially using the same pulse mechanism. But something is wrong. The data is corrupted. Not random, but consistently wrong. It's not the lower or upper nibble of the byte. I guess it's a timing issue. After some debugging, I found out I'm printing the entire array each time a new bit is received. Printing to an LCD takes time, which makes the receiver slow. The solution? I print only after the full byte arrives. And it works. Over time, engineers realized the pulse wire was unnecessary. Instead, they agreed on timing. If each beat lasts for a fixed duration, we don't need to send a pulse. But the receiver needs to know when the first bit starts. We can apply the same pulse logic here. The data pin stays high when idle and turns low right before sending the data. The receiver needs to read the midpoint of each bit to avoid collisions. For example, if each bit lasts 30 milliseconds, the receiver starts reading at a 15 milliseconds delay. If this sounds familiar, this is exactly how UART works. Let me remove the pulse wire to show it works. Now that we can send a byte, we can send meaning. Computers don't understand letters, they understand numbers. ASCII assigns numbers to characters. For example, binary 01000001 is 65 in decimal, and 65 means A in ASCII. Now, if I send the exact byte, and in the receiver I feed the entire byte into an empty character and print it on an LCD, it shows the character A. Now I can send multiple characters. The sender converts each character into 8 bits. The receiver rebuilds them into bytes and prints them all together. For now, I fix the length so the receiver knows when to stop. Now it is time to send a real message. But the length of the messages can vary, so we can't use fixed length. The receiver somehow has to know when a message ends. We can send an end character at the end of the messages. The receiver stops reading when the end character is received. And here is the message: subscribe to WireWolf. You should consider it, cause in the next video, I'll build a whole network using 4 of these setups, where each MCU can effortlessly talk to any of the other MCUs without collisions.